I'm from Haute Innovation in Berlin. We are responsible for this exhibition around here. We are doing this since, I think, 2013. Every year we are coming with new things. So have a look around. Now I will talk about additive manufacturing and the latest innovations we found in companies, in research centers. More or less, the additive manufacturing part in the exhibition is around that pyramid to your left. So it's about new materials. It's about bringing additive manufacturing from a niche application to maybe mass production. We have seen a lot of demo projects in the past. One of these were that 3D printed metal bridge. I've presented that maybe in 2014-15, where they started to do so. It's welded, by the way, welded layer by layer, and this bridge was ready maybe in 2019-20 around, and then it was stored somewhere, and last year it was installed in Amsterdam, so quite in the heart of Amsterdam, and that's Princess, I forgot her name, she was there at the opening ceremony. Quite interesting to see. By the way, there is a robot to show the welding, the additive process. That's an image of the video, how it started. This guy is called Joris Laarman. This is the founder of the company MX3D, which uses the bridge to develop a technology around this 3D printing process to industrialize the whole thing. So one trend in this area is that additive manufacturing is now jumping into broad industrial applications. We have a part on display also printed with the technology of MX3D called the so-called WAM clamp for the oil and gas industry. That's the process to do. From the image, I thought that it's tiny little piece like this, but you see it's massive. It weighs 50 kilogram. It's on the opposite side, so you can't see it from here. It's lying down behind the pyramid. So it's prepared for a gas, oil tube, maybe for hydrogen as well, installation in the industry, so an industrial application. We also have the finished part of that flange in the exhibition, made from bronze, to show also the wide range of materials that they can use in their process. We got this clamp from the 3D Pioneers Challenge, where we are in the jury, where we are a jury member, so we got to know this. That's where we got this from. Another piece we didn't get is that one, showing the potential for the aircraft industry. Of course, you know that aircraft is related to lightweight, reduction of material also means the reduction of CO2 emissions, so it's perfectly prepared additive manufacturing to be used in the aircraft industry. This part shows the massive mass reduction you can achieve by using 3D printing. 65%, that's a number. So we will see more of this in the aircraft industry, but we also will see more of 3D printing in the car industry. Now the prices went down for additive manufacturing parts, down, I would say, 10 to down to 10% of the price that were some years ago. So now the big companies, the big car manufacturers are all investing into 3D manufacturing centers like Volkswagen, BMW, all these. Audi, so I show some parts. This is, by the way, the first car where the whole components from the outside are printed in 3D, printed in plastic. I showed this image, I think it was 2017, as it was said that this is the first car mass-produced in 3D printing. Should be on the market by the second quarter of 2019. It had a delay. In that times, it was something like a construction between an Italian car designer and the Chinese production, LSEV. Then it turned into something which you could find on Kickstarter. So they started a Kickstarter campaign to get the money from. That was end of 2019, and finally it's now on the market. The company name changed to XEV. It's an Italian company. First they said the price is 7,500. Now they are selling the car for 15,000 euros. Why not? To show the potentials, first they had 2,000 parts in the how do you say, in German it's Karosserie, the outside of the car, and now it's just 57 just by using 3D printing processes, and they have a smaller one, Kitty, for just, I think it was 12,000 euros. You can order this on their website. Then I would like to leave the industry, or maybe jump into another industry, because additive manufacturing can also help to reduce CO2 emissions, and especially in construction, that is something which could help. I showed this image yesterday because we all know we are overstepping ourselves too much CO2 emissions in the last 50 years. I would say in 2020 the global footprint was 160% of all the resources, so we have to change this, and construction is perfectly a perfect industry for this, because 40% of all CO2 emissions come from that area. So why not 3D print houses in future, because that could reduce. They say maybe 40%, maybe it's 50%, maybe it's 70%, because you print houses not massively, so you print houses just with tiny slices. That's the first 3D printed house been ready, I think 2 years ago in Germany. They have started an initiative in Africa to give people houses, affordable houses, because there will be more than 2 million people more living in just in Africa by 2030, and that means they need houses. So why not having the possibility to print a house just in 12 hours with a cost under 10,000 US. That's a company called 13 Trees, an initiative from Kenya, and they came up with this house, and they say you could save 70% of the CO2 emissions just by changing the way we set up houses and use 3D printing. That's, by the way, the first house. They call it House Zero from the US. The first one designed for a way to use 3D printing and wood concrete in a way that it's ideal plant to use additive manufacturing. That's a design, I would say, I love that one. That's a printer. It's called Icon from a company from Texas. You can print 3 meters high, so it's just one storage, but why not? And they start selling houses with a 3D printed storage. Just some months ago, you can decide if you have 2 or 4 bedrooms or something. That's the interior. Always a combination of wood and 3D printed concrete. Then you would say, okay, concrete, why they use concrete? Maybe they change also the material in this, and they do. By using concrete, maybe you know that we have a problem with getting sand. So they start to exchange sand with recycled glass. That's a research project in Singapore. So they first robbed the sand from Indonesia. Now they change. I don't know. Yeah, I'm joking. These are the researchers. So they came up with the idea of having a concrete material for 3D printing where you have recycled glass in it. We found also technology in Italy. Studio Oberhauser did a furniture piece where they also use recycled glass instead of sand for the 3D printing process. We could see additive manufacturing as an enabler for green mobility. And now I would like to show you a piece we have on display. It's this bicycle, Canyon, the company, where the frame is printed in metal, just 2 kilograms of weight it has, and they start to think about recycle all the components that are used in a bicycle, and also work with monomaterial. So reduce the weight, reduce the resource you use, and work with monomaterial because that is easier to bring back into the circle. Maybe you've heard about the Hyperloop, that we would love to have a demo project also in Europe. Switzerland, I think, is working on a line. The first will be Holland. They are starting to set up a pilot route just for freight at the beginning between Rotterdam and Amsterdam. And then there will be a loop probably around Europe, Central Europe, Düsseldorf, Frankfurt maybe, and then back to Rotterdam. For a Hyperloop with a high speed of about 1,000 kilometers, you need a good braking system. And the winner of the 3D Pioneers Challenge from this year is a bellow rail brake from researchers from Zurich, by the way. So probably neighbors from you. They print, this is printed in one piece. The movement to brake they got from bringing oil pressure into the braking system. You see the hollow structure inside to reduce the amount. We have that piece. It's actually smaller than it looks like on display. It's like this. So no need for more. That's the piece which was presented at the 3D Pioneers Challenge final and showed the functionalities. We saw a lot of developments in bringing new materials into 3D printing processes like copper. You probably know that copper is not easy to print with these laser technologies because it's quite reflective to the laser, and with heat it's not working so well. a company called Additive Drives. They found a way to print copper, and they're using this for for copper coils for electric motors in future. First for the development of the motor, but then I think also for the production process. We know a company from Berlin called Xerion. They work with an additive printing process where they use filaments where they have metal inside, so metal filaments. So they print the metal filaments, then they debind the plastic in the filaments from the printed part, and then they sinter it. So it's a three-phase process, which works quite well, and they are now able to print also in copper, and they are able to print multiple materials like ceramic in the center and zirconia in this case and stainless steel around the ceramic, which is quite interesting for the car industry and some industrial applications. Then it's about batteries. We found a company called Blackstone Resources from Switzerland. They invested in a production plant in Saxony right now, and they are investing it, printing a battery system in solid-state lithium-ion batteries with a boost of 20% of energy density. So that are the plans for the manufacturing facilities. I got this from a little video, so there's no more to say about that. The 3D printing batteries should be more long-lasting, faster charging, so all the things we would love to have in electric mobility. I just click through because I don't know so much about the details. Yeah. One of the last trends we see in 3D printing is that also circular solutions can be found in 3D printing, like that recycled materials, for example, can be used. We have a boat on display, so the piece is smaller than it's expected from the image. It's the gray one where the two guys are standing in front of. This is 3D printed by recycled polymers from a company called Raw Ideas from the Netherlands. The idea is that you say, okay, I want to have this boat, and then you sketch it, and then they print it. So that's the idea. And you can do that. They offer the system on their website. Another company from the Netherlands, from Amsterdam, is called Actual. They offer similar process or similar idea for interior solutions like room dividers or acoustic absorbers. They offer a system, so you sketch something and then they do a design from it and they print it with bio-based printing materials in that case, and then they offer a circular concept, like they offer a take-back system. So they offer you 10% of the price you pay for the piece to get it back, because they know exactly which material they're going to use or they did use, and then they recycle the material and print again. So that's how it could work in future. Or if you just use a monomaterial, that's a project VD did with Oechsler, a 3D printing service divider. So they first thought of why do we mix materials in products like backpacks. In that case, the backpack is just made from TPU, from one quality of TPU. Also, the pads, the pads are printed in TPU. This could also be used in furniture industry. We have that seat on display over there. So in that case, it's printed TPU and wood. why not? You can imagine that this could also be an application in the car industry. This seed does exist. It's for Porsche. They started to produce that a year ago. We tried to get that seed, but it was easier to get the designed seed chair than to get a chair from the automotive industry. So it's always quite difficult. When you have a look to the circular economy concept, then you have a technological circle where all the materials should be in that has a high value, like metals, or which are synthetic, like plastic, to keep them and not to let them go into nature, because the biological circle is for materials that are natural and keep them natural. We also found 3D printing projects, 3D printing materials like this lignin-based extrusion process where the final product is biodegradable. That's the printer from a town in the south of Germany. That's research. Interesting to see how far they could come. And now I would like to introduce our next speaker. Now I'm talking 30 minutes. From EMPA, Gustav Nyström. So they develop a printing ink to set up disposal electronics. Do you have your presentation on the computer? So these are the two guys, and now I would like to thank you for the attention and for the interest. And they are selected. You can thank you. They were selected as one of the best innovations from the Time magazine, by the way, just a week ago for this year's, and they will talk about this biodegradable paper battery which we have on display.